Okay, here we go. Unit 2, Day 2, your homework prep, adding and subtracting polynomials. Now I'm going to be moving through the video pretty quickly, which means you'll probably have to pause it as we go through in order to give yourself some time to copy some things down. Top left-hand corner, Roman numeral 1. If you guys will copy down combining like terms. I also want you guys to copy down this right here. This is basically giving you what I want you to do in this particular section. I want you to add and subtract the terms that have, this is key, the same variables with the same exponents. You're going to hear me say this a lot throughout the year. Adding and subtracting is actually more difficult than multiplying and dividing. You can multiply anything. You can only add or subtract like terms. In other words, terms that have the same variables with the same exponents. Take a look at your first example that you copy down here. There are 3 terms there, but only 2 of them are like terms. In other words, you got to have the same letter with the same exponent. So you can see here in this term here, I have a p to the third, and over here on this term here, I also have a p to the third. Those 2 terms are like terms. They can be combined. So over here I have 12 p to the third. Here I have a. Together, that gives me 20 p to the third. Well, what about the one in the middle? It does have a p, but it's p squared. Therefore, it's not a like term, and it cannot be combined through addition or subtraction with the other term. So you just write it down, and there's our answer. Let's take a look at the second example. There are 4 terms here. There is an x term. There's an x squared term. Remember that 5x squared and the minus 3x are not going to be like terms. Why? Because this x has an exponent of 1. They're not exactly the same. Okay, the only things that are like terms here are the minus 6 and the positive 8. In other words, the normal numbers, the integers. And so I'm going to go ahead and combine those. As I'm writing this down, I'm also going to keep an eye and make sure that I write this in standard form. In other words, I'm going to write it in the greatest degree, the least degree. So I'm going to start there with that 5x squared, because that's the greatest exponent. Then I'm going to go to the 3x to the first. Now I'm going to be careful here also. Notice that that 3x is being subtracted, so I'm going to make sure that I have a minus 3x. And then the minus 6 and the positive 8 are going to have a little tug of war. The positive 8 wins by 2. Okay, that is now simplified. We can't take that any further. I have 2 practice problems over here for you to write down. Go ahead and take a chance to copy them down. And I'd like for you to pause the video and take a shot at these by yourself. Look at the 2 on the left as an example, and then unpause the video and I'll work them with you. Okay, first one. The only 2 terms that are like terms are the ones in the middle, because they both have an x to the first power. I'm going to write the x squared down first because it has a higher degree. And when the 2x terms combine, they're going to have a little tug of war, with the minus winning by 3, that's a negative 3x. And then the 7 is going to come down with no one else to interact with. Notice in all these problems too, that when we add and subtract these like terms, we're not changing the exponents. In other words, we're just trying to figure out how many x squareds we have, and how many x's we have, and so forth. Okay, last one. 7 different terms going on here. I'm going to start with the greatest degree. 4x to the third positive, plus 5x to the third. That gives me 9 of those x to the third. Then I go to my x squared. There's only 1 x squared that's being added, so it's plus 6x squared. Then I go to my x's. There's a positive 6 there. There's a minus 1 there. So positive 6 take away 1 is a plus 5x. Okay, and then lastly here I got my normal numbers. Negative 1 and negative 9. They're both being pulled in a negative direction, both in the same team, so it's going to be negative, and they're going to pull 10 in that direction. That is now simplified. Okay. Roman numeral 2 down at the bottom. Copy this down. Pause the video if you need to. We're talking about adding polynomials. Okay, so here's a situation where you have like a binomial or a trinomial that you're going to add to another binomial, trinomial, polynomial. And copy this down in the middle here. It says when there is a plus between 2 parentheses, just drop the parentheses and combine like terms. In other words, these types of problems are essentially the same as the ones that we've just done. So I can rewrite this without the parentheses. I can already hear some of you say, does that mean we have to? For your notes, yeah, go ahead and do that. But on your other problems, you can notice that there's a parentheses in between the, there's a plus in between the parentheses. You can ignore the parentheses. Okay. Like terms are 4, and a plus 1n squared, that's 5n squared. Then here we've got an m that's being subtracted, so minus 1m. And then we've got two integers here, a positive 5 and a positive 6. Just make that a plus 11. And one on the bottom. Plus in the middle means we get to ignore those parentheses. So basically, I can write the problem as if there is none. Okay. There's something a little bit different that you guys haven't seen yet, and that's a term that has multivariables. In other words, it has an x and a y in it. Okay? Well, that is just an x to the first power and a y to the first power. That term can only be added with other terms that have an x to the first power and a y to the first power. They got to be exactly the same letters, exactly the same x. Okay, so that being said, obviously these two terms are going to go together. All right, so I've got 10 of those, and then I'm going to add a negative 3, so I'm going to subtract 3. That's going to give you 7 of those xy. Okay, next I have an x and a y. Order does not matter here, but technically mathematicians like to put it into alphabetical order. So I get a plus x, and I get a plus y. Okay, I'm going to give you guys a couple here on your own. Pause the video, give them a shot, and then unpause the video, and let's see how you did. Okay, so the first one here, I can lose the parentheses. Let's see what I got. 7x squared and 2x squared give me 9 of those x squared. And then a minus 3x and a plus 5x, that's a tug of war. The 5's going to win by 2, plus 2x. And then I got a positive 9 and a minus 2, another tug of war. The positive wins that as well, by 7. Second one, lose the parentheses. Okay. See, I've got a y to the third, but no other y to the third, so it doesn't get to combine with anything. I also have a y squared here with no other y squared. It's being added, there's 4 of them, so plus 4y squared. That's easy so far. Here I have a y term, I also have another y term here. We have a situation similar to the one on the top here. We have a tug of war. The 5's going to win by 3, so plus 3y. And then I've got two integers here, both of them on the negative team. They're both pulling negative, so 11 and 4 give me 15. Okay, backside. Flipping over the top left-hand corner. Go ahead and copy this down on memo 3, subtracting polynomials. This is where it starts to get a little bit more difficult. Go ahead and copy this all down. I know it's a little bit wordy. You guys can handle it. Because with a subtraction in the middle of the parentheses, you must subtract each of the terms in the second parenthesis. Basically, you will change the sign of the terms in the second parenthesis, then combine like terms. Let me say this another way. If you look at number 1, this little minus sign is going to subtract each one of these 3 terms. So it's almost like a little distributive problem. I'm going to subtract the 5 into the 4th, I'm going to subtract the minus 5 into the squared, and I'm going to subtract the a. So you might see me draw this little hippity-hoppity here, just to help. Now, whereas there's a plus in between the parentheses, you might not want to write the whole problem without the parentheses. I am going to make you guys write this second step, because it will eliminate a lot of mistakes. Okay, so let's do it. Go here. The first parentheses is the one that's being subtracted from, so it doesn't change. But the second one here, which you can see here, we have a minus 5 into the 4th. And then we're going to subtract a minus 5 n squared. So the opposite of a negative. That's adding 5 n squared. And then we'll subtract the 8. And you can see all of these signs going from the parentheses to the second level of problem here, all of those signs have been changed. Now, you just add subtract like that. here. The 7 is positive, the 5 is being taken away, so it's 2 into the 4. Then we've got n squared. There's a minus 2 and a positive 5. Positive 3 n squared. And then there's just that one lone integer at the end. Okay. Let's take a look at the second one. Once again, I'm going to distribute that negative sign each one of those terms in the second parenthesis. So here I'm going to subtract the x squared and subtract the minus 9. So each one of their signs will be changed. The first parenthesis stays the same because it's the one that's being subtracted from. Then we have minus x squared. And the thing about this, you're going to subtract a negative, it's going to be a positive 9. Now we can finish the problem. Let's see, x squared. I've got minus 10x squareds here, and I'm taking away 1 of those x squareds there. So they're both negative. One's 10, one's 1, so that means they're going to end up 11 in the negative direction. Then we're going to take away 3x. Then we've got 2 integers here, both plus, so they can stick in 16. Copy down these 2 here to work on your own. Give it a shot, pause the video, see how you do, and then you can watch me work it. Okay, first one here, I'm going to go ahead and distribute that negative. So you're going to see me change the signs on all of these. So minus 3x squared, minus 5x, and then plus 4. Okay. Here are my x squareds. 6 minus 3 is 3. Gone. Then I've got my x's. Now, minus 2 and minus 5, so they're both going in the negative direction. It'll be a negative, and they go 7 in that direction. Then my integers here are both positive, so 5 plus 4 cancel out. Second problem, let's distribute that negative each one of these terms. So I'm going to subtract 10y and then add a 3. There's only 1y squared, so 9y squared doesn't interact with it. There's only 1y, so minus 10y doesn't interact with it. And then we've got these 2 integers here that have a tug of war, and the 5 is going to win by 2. Okay, in the remaining part of your homework, I want you to copy down these 6 problems. And I want you guys to work these on your own. Matter of fact, these are going to be basically like a normal homework where you have these 6 problems to work. But I'm going to throw you a bone. I'm going to work some of these, or maybe all the problems. I'm going to work some of these problems on another video. It'll be below this one. Therefore, if you get stuck, you can watch the video. Also, you can come in for tutorials and get them all right. Thank you very much. See you guys soon.